All right. Hello, everyone. Welcome to Space City Rocketry's bi-weekly meeting on November 15th, 2022. Hope you've all been staying warm the past few days and staying dry yesterday. It would be a shame if anyone lost a left AirPod yesterday and then found it later on. So hopefully that didn't happen. On the agenda for tonight, we have the shout outs, which low-key, this list of shout outs is kind of crazy. And I think the whole team deserves a shout out, but yeah, great stuff. Then we'll have a Kahoot. Unfortunately, because we're a little broke, we don't have any prizes, but you can win bragging rights, which on this team reign supreme. Next, we'll go over the design summary in this week's new task. Then we'll talk about designs needed, not technically related, but about these stickers and why they're making a comeback. Then we'll be continuing our discussion about the anonymous suggestions box, and then also taking a look at some upcoming events before ending it off with sub-team updates. Cool. So for shout outs, we have this long list of members. So first, I wanted to say shout out to the whole team. I think this list is just a small percentage of everyone who really deserves a shout out. I think all of you have been putting in some really good work, especially after the PDR, to make some changes to our designs, finalize some things, and really just make some good progress on our project. So first, shout out to Frankie. He helped create an active cooling system design. If you want to learn more about that, I'm sure Payload will be talking about that in their updates. Scott, shout out to you. You ran through the storm without an umbrella yesterday to get to the lab. So I guess we should say swam through the storm, but yeah, that takes a lot of courage. So shout out to you. Also, big shout out to some alumni, Emily, Alex, and Gustavo, for advising with the Payload cooling system. They've offered some really good input, and I'm sure Payload will be taking that into consideration as they finalize or come up with their cooling system designs. Orlando, slaying with the PCBs. I can personally attest to this. This man taught me about PCBs and utilized the whiteboard very well. So shout out to Orlando. What?
Just Orlando?
I'm continuing.
He's going down.
I'm going down the list.
I think she wants credits for teaching.
Oh, well, we'll see about that. No, I'm playing. Also, Sam too. Really, all of avionics. I was in their lab session, and everyone was doing a really good job of either learning or teaching, and it was just a very wholesome environment to be a part of. But yeah, special shout out to Caleb as well for slaying with the ground station ideas. I believe he's online, so yeah, shout out to you, Caleb. Also, Amy helping out with the sewing of the machine threading for recovery. Shout out to Leo for finishing the Max Q project on his own. I would highly encourage y'all, if you're interested, to take a look at what Leo did. He even made an instruction kind of manual on how to go about it in OpenRocket, set everything up and get a actual very good value that we're happy with. Ariba for being a very consistent and reliable member with analysis. Shout out to her. Shout out to Celine for finding alternative sewing machines. And also, it is her birthday today, right? Happy birthday, Celine. And lastly, huge shout out to Joe. So far, she's been an excellent project manager. And to be honest, she's really carrying SCR right now. She has a midterm tomorrow, so I want everyone to go and wish her the best of luck. I believe it's a discrete math. So for those of you who know that, I've heard it's pretty bad. So good luck, Joe. We're very proud of you. And thank you for doing all you do for the team. We really appreciate it. Next up, we got the Kahoot. Yeah. So this is Thanksgiving themed. So we'll see who is truly cultured. Yeah. What? I'd not say that. Caleb, I think you spelled your name wrong. Oh, hey, yo. God. This is going on YouTube, by the way. I hope you're proud. All right, let's get started. They're calling me out. All right, question 1. What year was the first Thanksgiving celebrated? 2020. I have no idea what these answers are. I just found this Kahoot. Hey, 12, right? Damn. Yes, it is. All right, true or false? First Thanksgiving was a 3-day harvest festival in which Native Americans and early settlers gave thanks together. Hey, true. Oh, Nikolai taking the lead. Well, which Native American tribe inhabited the area surrounding the site of the first Thanksgiving? Dang, y'all are really cultured. Y'all really built like this. Hey, shout out to Kalba. All right, question 4. Where was the first Thanksgiving celebrated? Hey, shout out to my Houston homies. Houston Thanksgiving, you know what's up? No movement on the leaderboard. All right, what day is Thanksgiving celebrated on? Right. Nice, the 4th Thursday. It was on the calendar, people. Amy. Amy is the Kahoot queen. No one's beating her. What year did Congress make Thanksgiving an official national holiday? Oh, my bad, bro. My bad. Hey guys, it was on the picture. Barca. All right, true or false? Turkey was served at the first Thanksgiving. There's the picture. If anyone didn't know what turkey looked like. False. You fools. Just kidding. Most of us got it right. Palma. Wait, does this mean I kick him? Oh. Hey, question before I'm kicking the whole leaderboard. All right, what is the average number of calories consumed on Thanksgiving? All right, I think this was.
I love how only one of these is in units of calories.
Yeah, wow, we're so smart, guys. Nice, nice, nice. Which president proclaimed Thanksgiving a national holiday on October 3rd, 1863? Oh, I'm gonna block that face.
Yeah, the other ones.
Hey, I didn't make this, all right? It's a little Thanksgiving fun. Nice. Okay, true or false? There are 4 towns in the United States named Turkey. Is it 4 or is it 5? It's true.
Yeah. There's no.
Bro, what? Dude.
Thank God we're not Mr.
All right, question 11 and 14. The 4 towns can be found in the states of what? All right, come on, y'all.
Oh, wait. Paris is I live in Paris.
I think I found the right level of difficulty for the team on this Kahoot. Wouldn't you agree? Barca 10K. True or false? Hey, my bad, man. This Kahoot kind of sucks. Kalbe making a run. All right, question 13 and 14. Double points.
You suck.
Since 1924, which department store has put on a Thanksgiving parade? Who here shops at Nordstrom? All right, you can leave. Nice, Macy's. Ooh. Multi-select. Why do these? They need to have writing answers on Kahoot. It'd be funny. Why are you asking me? Oh, wow. Nice. The podium, which means nothing. Amy. Calvin. Dang, 14 out of 14. Barca. Give it up for Barca. All right, we're taking a look at the chat because it's popping off. All right. Who's colonizer? Yeah, what the heck? Are we gonna talk about that? I didn't look OG. Thank you, Zach. Wow. State of Paris. The goofy average. Elementary school class. Very nice. Very nice. All right. Very good job, everyone. What the heck?
Yeah.
I'm good.
Damn. You're on vibe with the Kahoot.
Okay, moving on to more serious matters. The design summary. So this is something Joe and I thought would be extremely beneficial for the entire team as a whole. We noticed the amount of stress last year and kind of cramming that it took for the technical report. Shout out to everyone who is in the architecture building. I think Brandon was there, Gustavo, Irvin. We were there, I don't know how many hours, but we were like struggling to put everything together. And like all the way like we write the tech report is through this website where you can like pretty much like code what you're writing. It's kind of cool. And the way the figures were showing up were always messed up. So we had to keep on like re-uploading figures and then reorganizing everything. So if you take a look at the or at the Zenith Tech report, you could find a lot of mistakes. So in order to avoid that, we have the design summary. So it's a single document for each subteam to give them a place to define their final designs for Shasta 6. For payload, you'll notice that two subteams do not have a design summary in their Google Drive. One of them is payload, as they'll be adding to their statement of work, which will kind of encapsulate their year-long work of their experiment. And then propulsion, I figured it would just be kind of pointless. You're just talking about the motor. So if you want, you guys can help out analysis and a little bit of structures, because structures will talk about the motor block and analysis will just talk about the stats of the motor. I don't think it's too necessary and it's not really useful, and it's just adding another task. So you guys get a free pass for this one. As I said, it'll help prepare with the technical report, but also looking into next semester with manufacturing, I think will be extremely beneficial for all of us to be able to refer to a single document with all of our finalized designs, and we can point to something and say, hey, what type of fasteners are used on the avionics bay? And you can go to structures and they'll have it stated there. In that regard, it will also help with kind of cross member integration knowledge. I don't know what I'm saying, but like each member, if you're say on payload and you want to learn more about the overall design of the rocket, you can go to analysis's design summary, learn more about where different things are placed, the weights of each components, things like that. And it should allow each member to learn more about each subteam without having to dig too deep or ask too many questions or move around too much. So that is what that is about. And we'll be due before finals. So Saturday, December 3rd is kind of our final deadline for finalizing all these designs. And this will also be due then. Speaking of designs, we do need designs for the following items. Stickers. So both physical stickers for fundraising. You can see some of the stickers on my laptop. It's kind of cool. They were from the year with Oberon. So when Emily and Alex were leading the team, they came up with some sticker designs and got them printed out and sold them. So we're going to sell those for fundraising because, you know, we're broke. And then we'll also have stickers for our Discord server because we are nitro boosted or level 1. So we're able to have custom stickers. So I think it'd be pretty cool if we had some kind of memes or some good reactions on there. That'd be pretty funny. Also t-shirt designs for AIAA as a whole. Ignore the date there, that's not right. But yeah, if you have any t-shirt designs, they would be very welcome to see them. And then if you do end up winning, you get a free t-shirt with your own design on it. Also looking at the Shasta 6 rocket design. So we have two really good submissions so far. If you think you can do better, please feel free to submit or just submit anything. Yeah, we want to open it up this early. Last semester or last year, we didn't really consider it until late in manufacturing. So we're giving you guys the time to think of something, come up with something, and hopefully yours is chosen for Shasta. I think we'll take a vote on Shasta's rocket design, by the way. So. All right, next is the anonymous suggestions box. So we have a Google form. There's a QR code there. You can submit any suggestions you may have, but it also acts as a safe space to express any discomfort that you're facing. If you're stressed out about something on the team and you would like a place to put that, then this is the place to do so. It can also be found in the Space City Rocketry Drive. So feel free to scan the QR code if you are interested in suggesting anything. I think one good thing about the team this year is that I feel like we're all striving to improve, especially coming off of Zenith last year. So this gives us a really good spot to do that. And your concerns and every suggestion will be taken seriously and something that we will take a look at and give a lot of thought to. So If you're interested, scan the QR code or find it on the drive, or just message the Discord and we can drop the link there as well. Upcoming events. So this Thursday, November 17th, we'll be having a bake sale in the Student Center South from 2 to 6 p.m. If you are interested in helping out and signing up for a shift, giving your best shot at selling cookies and maybe some other items that we are looking at deciding, then you can use the QR code there to sign up for a shift. A reminder for the leads to please sign up for shifts as well. We need help. But yeah, next we have our student funding organization kind of presentation opportunity. This is really exciting, especially in the midst of the fact that we are broke. Thursday, November 17th, Joe and I will be going to the dean's office, quote unquote. I don't know where that is, but we'll figure it out. And we'll be presenting, I think it's a 5 to 10 minute presentation about SCR, pretty much why we deserve money, what we've done in the past, and hopefully they really like us and decide to give us some money. But yeah, next social is at Dave and Buster's, Tuesday, November 22nd. We're still looking at the timing for that, so we'll get that out to you as soon as that is decided. But there will be free food and drinks and bowling. Anyone who wants to play bowling or basketball, you might as well not show up because I'm going to kill you. Like, it's not even close. I'm going to beat you. So, well, actually, you should show up, but yeah, you won't win if you try and play bowling or basketball against me. So yeah, I stand by it. And what? Come and play me. And it's at the Marquee Entertainment Center, so please come out to that. Joe, shout out to Joe. She made a really cool Google form with everything, organizing carpools and everything like that. So please fill out those Google forms for the upcoming events. We good there? Cool. Now we'll get into sub-team updates, starting with Bromar and analysis.
Okay. So for analysis, in regard to completed tasks, Leo was able to finish his max dynamic pressure project, which you can see in the top right figure. So huge shout out to him for that. Besides that, we're working on quite a few things right now. The biggest thing being the design summary. So we're trying to get that done as soon as we can. We've been collaborating with structures. Brandon, shout out to him, he showed up to lab today. And we were able to assign a lot of our members to each other sub-team so that they can keep them up to date with any design changes that happen. And in addition to that, we're looking into starting a CFD to see if protruding fastener heads affect drag a lot. So hopefully we'll get some concrete answers onto that. And then future tasks, of course, just continue to collaborate with structures and any other sub-teams regarding any other analysis to be done. And that is pretty much it. Thank you.
Thank you, Bromar. Thank you. Now we'll have avionics with Raj and Sam, sub-team with its own room.
Okay, cool. So Sam's going first. So, all right, Sam, you there?
Yeah, I'm here.
All right, Bet, take over.
Okay. So some of the tasks that we have completed for avionics is our initial ground station design. As you can see on the screen, Celine drew a beautiful design with the little cover that we're thinking of doing. We also have a PCB pinout for our schematics. So as you can see at the top, there's like a little picture over there. And then we did like a soldering skills lab a couple of weeks ago. So there you go. You see Jacob and Sochi and Eggman. And our current tasks right now are our PCB schematics. We're still looking for antenna selections. And right now we're trying to look for our secondary COTS flight computer. And for our future tasks, we're finalizing PCB boards. We're trying to make our PCB boards in KiCad, and we're focusing on modularity. So once we have one PCB board, it will be kind of the same thing for the rest. And then we're doing SRAD flight computer programming. And then instead of using Python, we switch over to C++. And then overall slaying and overdrive. And then right now I'm gonna go ahead and introduce Orlando, one of our avionics members, and he's gonna go ahead and talk more in depth of our PCB boards.
Hello, everyone. My name is Orlando. I'm from the avionics team. And last lab, we worked on making the schematics for the PCB boards, the SRAT PCB boards. And I just taught the members just how to work the program, the KiCad PCB design program. And right now we're just looking forward to getting the schematics done. Most importantly, we need the schematics just to have the documentation on the computer. So like in the future, like if new members like want to work on the same computer or have a point of reference to which to work on, they'll have that. And yeah, we're working on making the libraries for the symbols. So all the components that we're gonna put on the PCBs, we're still making those for the schematics. And yeah, that's about it. Thank you.
Right. Thank you, Orlando. So Orlando is one of our avionics members. He has been working really hard on these PCBs. Me and Sam have been,
Woo, Orlando.
no, right? So he's been working really hard
Thank
on
you.
it. It's been just really awesome. So yeah, oh shoot.
Just click on this.
Okay, there we go. So for our fun facts about avionics and what we've been done so far. So one of our members, Brandon, he is a master's electrical engineering student. He has coded this thing called an SITL program, which is basically a flight sim program, but for electronics specifically. And so what does SITL mean? Well, it stands for software in the loop. And the way it works is that it simulates sensory data and then uploads that to our flight computer. And then we see how the flight computer reacts as if it was flying in the air. So it's a really cool way to kind of ground test it. You can see here on the right, all of it's coded right now in Arduino IDE for C++. And it's a really heavy software that's going to be really useful in the future for avionics. And so another fun fact about avionics is that they can still. Sorry, we're just experiencing. Okay, there we go. Sorry, we're just experiencing technical difficulties. So on the middle, one of the things we do with avionics as well, with programming all that data on the flight computers, is that we send it out for telemetry. And so what is telemetry is the process of recording and transmitting the readings of like electronics. And it's usually done through ham radios like walkie-talkies or APRS, which is basically kind of like an automatic packet reporting system. So you can see here in the middle, all these pictures of the ground station and stuff. That's like actually me at Spaceport trying to connect to the rocket through telemetry. And so we actually do that through the ground station, which I have it right here. I'll let y'all like take a look at it. But it's basically this portable box that has multiple supercomputers inside of it. So like this year, we actually have like a Raspberry Pi inside of it that has like all the data reading out from the rocket itself. So stuff like how high it's going, the GPS, etc. All that stuff is integrated through this system inside this rocket. I'm sorry, not in the rocket, inside this ground station. And we program it using data acquisition software, and we integrate all the stuff like the antenna and telemetry through it. And it's just basically just a bunch of like computers like Raspberry Pis, displays, and antennas all in one box. So it's a really useful way to kind of carry it around the desert so that you're not like taking all this time using the computer and stuff like that. Other than that, that's it for avionics.
Woo, Raj.
Raspberry Pi, baby, let's go.
Raj is now passing around the ground station. This is why you should come in person. But I don't blame you. It's really cold. All right, next up we have payload with Kevin and Izzy.
Hello everyone. You'll still hear me, right? About the mic. Okay. Hello everyone. So last week we had all our members work on creating initial designs for both a passive and active cooling systems. And then on Friday, we had everyone present it to each other just to present them and then just discuss about them. I'll go more into detail about it in the next slide, but big shout out to Frankie for creating the active cooling system design. We'll get to see his design in the next slide. So our current task will be finishing the CAD designs for each of the sections. So this will be for the FCCU, the FECU, and the electronics section and tray.
Define important. Okay, I'll take over right now. So, to define those acronyms, the FCCU is the Flight Control Containment Unit. So it'll be the top
the, the top containment unit for the flies that are not under therapeutic hypothermia for our control portion of the experiment. And then the FECU is the fly experimental containment unit. So those will be the ones that are all cold and stuff. And then I hope y'all know what the electronic section and tray is. PCB board. But another thing that we will be focusing on is just to how to properly secure all of this within the bay, and we'll be working along with structures for that. So before our Friday meeting where we discussed all of the cooling system potentials, we met with structures a little bit to talk about how to fasten everything on the rails and how to keep that load from just going all over the bulkhead, you know. So yeah, we'll get into the active and passive cooling system in the next slide, and I will let Kevin take over to talk about heat transfer calculations real quick.
So we've been doing more work on the heat transfer calculations. After talking to Professor Gassemi, we are now trying to calculate how much energy the case will absorb after being in the outdoor environment. And then we will compare that energy with the energy it takes to melt the phase change material that will go inside the insulating case. And then if the energies for the case is about equal or less than the energy it takes to melt the phase change material, then we'll know that the temperature inside will be good enough to keep the flies at our desired temperature range. Then for our other current tasks, we'll be further developing the avionics side of the payload, as well as updating and revising our statement of work. So for our progress with the payload cooling system, we have the passive cooling system design that we shown before, which is just an insulating case with layers of aerogel to keep everything insulated within. That design has a big emphasis on the heat transfer and keeping all the heat outside from getting inside the case. And then we'll have a phase change material within the case to keep everything as cold for as long as possible. As for the active cooling system, with Frankie's design, we've been looking at a pump and reservoir system. So in the picture, the CAD that Frankie created, the bottom section will be a reservoir for water. And then it'll have two tiny pumps in it that will circulate the water through the little holes onto the upper section, which will be where the flies are. This system will turn on or off depending on what the temperature is, so that can reach our desired temperature range. We're still working on these two designs, and then hopefully with the decision matrix, we'll have our decision by this Wednesday, so we can move forward with our design. Obviously, we'll be looking at a lot of these substances that we'll be using. So what kind of phase change material we'll be using, and how to secure all the electronics if we do go with an active cooling system. So it'll be a lot of work after we decide on which one to go with. And also, thank you so much for all our payload members for showing up in lab and helping out with the design so far. And also thank you for the alumni for all that advising and funding.
I'll add on to the cooling stuff a little bit.
Yeah.
Yeah, just to add on to what Kevin said, thank you for all your work from the members and the alumni, and then everyone else that we've gone to for advice, our chief engineer, structures. We understand that the cooling system itself seems very intricate. It's a lot of work, a lot of dedication, and people are showing up with a lot of passion. So I have a lot of faith in our team to get this done. I've talked to Emily Humble, who's an alumni that donated, and we've talked about, and also Ravi, about making like possible prototypes going into those things. Kevin and I have talked about like possible compromises between the active and passive cooling system that Alex has advised on. So there's a lot going on, and we hope to excite y'all with everything we're getting done. Our future tasks are just finalizing like bill of material stuff, adding on to that, getting some purchase orders done depending on what we can buy right now and what's finalized. We will detail the upkeep instructions as we go along with stuff. Our big emphasis is on the cooling system right now. We'll finalize future testing. A lot more testing will be added and like conducted, and we will detail that in the statement of work, especially for our cooling system, our substances, our materials, everything like that. And then the SDL payload challenge submission is not due till about 2 weeks before the competition. As everything becomes more detailed, we'll have the amount of like risks and mitigations that they ask for in detail for that. That does have to do a lot with our score. And then we'll collaborate with other SCR sub teams and other SA Cup teams to get everything done. I know a team from Turkey is looking forward to meeting with us this upcoming couple weeks.
Thank you, Payload. Next up, we have propulsion with Parsa.
Hello, everyone. So we finally completed our motor design. We got a quote on it, which was kind of crazy. The nozzle itself was it was a few $100s. So I think our best thing to do right now is just we're going to try to look for a sponsorship, or we might just have to change the motor design. I was thinking about getting rid of the threadings on the motor, on the nozzles, and maybe just have some holes where we could screw it into the casing itself. One of our members introduced the idea of using an ammonium nitrate aluminum powder fuel, and also known as tannerite. So he's working on that safety document. L1 kits are still coming in, so we haven't gotten started on building them yet. And of course, our future task is to just get this motor made and test it out, get some thrust readings, get some pressure readings, and later on expand to an L2 motor. And that's it.
Next up, we have recovery with, seems like Christian lost the straws. So Christian.
What's up, guys? So, recent tasks, we finally finalized our shot core lengths. I think right now we're going to do with the 3 times the body length for both the drogue and the main sections to body tube. We're working on just finalizing quick link decisions for the calculated shot core courses that we plan to sustain. We're working on our gore designs, just generally getting our sewing machine to actually work. We're having a lot of issues actually getting the bottom of the thread. Brandon can attest to that. We were going through today. Working on the bulkhead layout. It's looking like in order to have both the CO2 and the black powder systems, the U-bolt's going to be slightly off center. So we're definitely going to be working with structures and analysis to kind of work through if that's going to work for our rocket. Finishing ordering materials and filling out the BOM with all the materials still going on. In the future, going to start working on that overview doc, getting all of our components in one place in the design for the recovery system. And we're going to start working through the spring testing plan. And since I did not explain what a quick link was, that little bitty metal piece with the white background in the center there, it's a quick link. Basically attaches different lengths of shot cord to each other. It can be sealed tight with the little threaded ends right there. You put a little bit of Loctite on there. It'll seal up nice and tight and won't come loose during launch. And it'll make sure the shot cord lengths will kind of stay in place. And that's it for recovery, I believe. Thank you, guys.
Thank you, Christian, and recovery. Last but definitely not least, Brandon with structures.
Hello. So for completed tasks last week, and I believe the week before that, we completed some of our designs using some of the feedback from the PDR and the alumni. They had some great stuff that we talked about, we went through. So majority of those are completed. Current tasks, some designs that we're still updating are the couplers. So more specifically, the rail material and the hardware and how exactly we're connecting everything together. So on the right bottom hand of the screen, you can see the previous design for avionics. So we wanted to have those screws coming through the bulkhead into the rails. We got some feedback from Alex saying that that might not be the best idea. And he gave a few suggestions in a direction that we should head. So we are thinking about some of that, about changing the material of the rails from G10 fiberglass to steel or some other type of metal. And then also using a helical insert, which you can see in the top right, to take the place of threaded inserts. So basically that
heel cleanser is just like I think of it like a spring that's shaped correctly to fit the male threads of a screw, and you can just put it into a hole and use it like threads. The next thing is the payload fastener size and location. We're communicating with them right now to make sure that everything is up to date and correct, so that we can make the best decision as to how to secure everything in there. And lastly, for current tasks, we are working with members' individual projects. So the rail button specifically, and then also the layout structure and fillets for the fins. For future tasks, I hope I'm gonna have that meeting with Dr. Blarby. He's been a tough man to get a hold of, but hopefully this Thursday I can go over there about 2 and we can talk about some testing methods and stuff. And lastly, manufacturing and testing composites, mainly with the individual member projects and stuff like that. Thank you.
Thank you, Brandon. And lastly, do we have any questions about anything? How bad someone's gonna get beaten bowling? How bad someone's gonna get beaten basketball?
What are we eating at
Food. The question was, what are we eating at Dave & Buster's? Whatever y'all would like. Just kidding. To be decided. We will see. If you have suggestions or want to eat something in particular, let us know, and we will see if we can make it happen. How much are the cookies going to be? For you, 1 TikTok. If you make a TikTok, you'll get a cookie. No, depending, well, we're probably going to stick with the same cookies that we've gotten. So $1 for the small ones, and then what was it? $3 for 5? $3 for 5? $4. Yeah, $4 for 5 small ones, and then $2 for 1 big one, or or for let me check. I don't know.
It's $1 per Walmart cookie and 3 for $2, and then $2 per Sam's cookie.
Nice. Thank you, Joe.
We're watching Minecraft.
Cool. All right, any more questions? Anything? No. All right, cool. Well,
Wait,
You gotta update it with how we found it.
Yeah, we need the sequel.
okay, I'll stop the
wait,
recording.
wait. Can we sing happy birthday to Celine?
Yes. All right. 3, 2, 1.
Happy birthday.
What's happening?
You.
What?
To you. Happy birthday. dear.
Happy birthday.
Happy.
Birthday to you.
Wow, that was beautiful.
We may not get money for building a rocket, but I'm pretty sure we'll get money for our singing. Yeah. All right, cool.